All right, I've got 3 fun exercises for you here. Find all the partial derivatives of the following functions. So we've got one unnamed function here. So find the partial derivatives of z with respect to y as well as z with respect to x. And then also do the same for the surface area of a cylinder. So find the partial derivatives, all of the possible partial derivatives for this equation. And same thing for the volume of a square prism with a cube cut out of its center. What a fun thing. So here's a drawing of what that looks like. So the volume of a square prism with a cube cut out of it, where the square prism has these dimensions x and y, and then there's this cube inside with z. So the volume is x squared y minus z cubed. So that's kind of a fun one to wrap your head around visually, at least. All right, you can pause the video here and try these out for yourself. We're going to go through the solutions now. In our first question, we have z is equal to y cubed plus 5xy. To calculate the partial derivative of z with respect to y first, we can consider these two terms separately. So we have y cubed, power rule makes that 3y squared. And then over here, we're treating 5x as a constant in front of y, and the derivative of y to the power of 1 becomes 1y to the power of 0, which is equal to 1, and so we're left with 3y squared plus 5x. For del z del x, we have this first term, which when we hold this constant, there's no x in here, so this becomes a 0. Over here, x is a derivative with respect to 5y, which we're holding constant. So kind of imagine that we're bringing x out to the side, and then the derivative of x is, so x to the 1, just as we had over here, becomes 1x to the power of 0. Anything to the power of 0 is equal to 1. So this whole term becomes 0. This term becomes 5y times 1. So overall, del z del x comes out to 5y. Nice, and now for the surface area of a cylinder, its partial derivatives. Let's do the easy one first. Del A, del H. So this term here, it has no h in it. All the rest of it we treat as a constant, so that becomes 0. For the second term, we have 2 pi r h. In here, the h, when we treat 2 pi r as a constant in front of it, and then take the derivative of h to the power of 1 becomes 1h to the power of 0, so that becomes equal to 1, leaving us just with 0 plus 2 pi r, and so that's just 2 pi r. Relatively more complicated one, but not too bad. For del A, del r, we have, for this first term here, we treat 2 pi as a constant, and then r squared, power rule, that becomes 2r. And for the second term, this is similar to what we had over here, but now h is the constant, r is the one that we're taking the derivative of, so r to the power of 1 becomes r to the power of 0, it just becomes a 1. And simplifying a bit, this becomes 4 pi r, and this becomes 2 pi h. And then finally for our square prism, for the volume of our square prism with the cube missing from inside of it, we have v equals x squared y minus z cubed. So we have 3 partial derivatives here, dv dx, dv dy, and dv dz. Luckily, they're all pretty straightforward. So let's start over here with one of the easiest ones. So for dv dz, x squared and y, these are both constants, but they're alone in their own terms, so they become 0. And then, so the only term that's relevant to us here is this negative z cubed. From the power rule, because we're interested in z here, we convert from z cubed to 3z squared, retaining the minus sign. That leaves us with del v del z of negative 3z squared. For this one here, maybe this is the easiest one, del v del y. So for del v del y, the z term here can be ignored. It's a constant. And so the only term that's relevant is this one here. We're differentiating with respect to y. So x squared is treated as a constant. Y to the power of 1 becomes y to the power of 0, which becomes a 1. And so all that we're left with is del v del y equals x squared. And even this one isn't too hard. So in this case here, for del v del x, z squared, this term here, again, is just a constant, so it becomes 0. And up front here, we treat y as the constant that is in our constant product rule here. And then we use the power rule to convert x squared to 2x. And so we're left with 2xy minus 0. So del v del x is really just equal to 2xy. There you go. Up next, I've just got a really quick one for you on partial derivative notation.